There are different scales of temperature that we use in science, Celsius, Fahrenheit, and Kelvin. And Celsius and Fahrenheit are both originally based off of, well, one of them's not originally based off of, but now it is, the freezing points and the melting points of water, or excuse me, the boiling point. So here's the boiling point of H2O, and down here we'll say is the freezing point of H2O. And if you have any experience working with Celsius, then you know when we're talking about Celsius that the freezing point of water is 0 degrees Celsius, and that the boiling point of water is 100 degrees Celsius. So the difference between those two is 100 degrees. So here's my boiling point, and here's my freezing point. All right, so then what about Fahrenheit? Fahrenheit says that water freezes at 32 degrees Fahrenheit and boils at 212 degrees Fahrenheit. And that is a difference of 180 degrees. So they're based off of the same physical property, but in one case, whoever came up with the Celsius scale says, I'm going to divide that into 100 parts, and so we have 100 degrees separating freezing and boiling points of water. And Fahrenheit, we find that they separated it using 180 parts, 180 degrees. And so we have different numbers associated with them. Kelvin actually is very important because it talks about absolute zero, that 0 Kelvin is the point at which all molecular motion stops. We can compare here the freezing points and boiling points of water and see that 273 K would be the freezing point of water, and 373 K would be the boiling point of water. And what you find here is that Kelvin and Celsius have the same number of degrees separating freezing points and boiling points, which is nice. That turns out to be kind of handy sometimes. When we go to convert them, we have two formulas. And in the first one I've got up here, I'm showing that we can go from Kelvin to Celsius and back and forth using this first equation. And this is one that you often will be asked to memorize for an introductory level chemistry class. The second one, converting between Fahrenheit and Celsius, I personally don't ask my students to memorize, and I have to look it up every time I need to use it. I hope that doesn't make you think less of me. But I would provide it on an exam or an assessment if you needed it. So let's do some examples. We have a person who has hypothermia, and their body temperature is at 29.1 degrees Celsius, and we want to know the temperature of the person in Fahrenheit, because when we talk about body temperatures, we often talk about Fahrenheit. When you say that your temperature of a healthy human body is around 98.6, that's 98.6 degrees Fahrenheit. So I'm going to recall my equation that Fahrenheit is 9/5 Celsius plus 32, and I'm going to plug in my degrees Celsius right here in for the C. This is 29.1 plus 32, and so my degrees Fahrenheit will equal, I'm just going to double check my math here on my calculator, so 9 divided by 5 times 29.1 plus 32, I get 84.38. My measurement here has three significant figures, so I will say that is 84.4 degrees F, which is pretty darn cold, given that healthy human body is 98.6. Let's look at another example. What is 25 degrees Celsius in Kelvin? Well, we know that Kelvin equals Celsius plus 273. So I just plug in my Celsius right there and say 25 plus 273, and that is equal to 298 K.